Hello everybody, my name is Paul Beckwith, and I'm somewhere here behind this gorgeous dog, Newton of course, and Newton is now a high albedo dog, so because of his latest haircut, removing probably a few pounds of thick fur, you know, and it was getting a bit dirty in spots and matted. You know, it was causing him to be too hot, and with our heat wave, we needed to mitigate. So we turned Newton from a low albedo dog to a high albedo dog. So always doing our little bit for climate. So what I want to talk about in this video is a recent paper that came out called Arctic Stratospheric Polar Vortex Collapse Amplified South China Extreme Rainfall in April 2024. So we have an interesting phenomena here whereby there was a very strong stratospheric polar vortex up in the Arctic, and over the space of a few days, it basically collapsed and the winds reversed. We had a sudden stratospheric warming and the winds reversed, and there was downward propagation of the effects of this collapse of the high up in the stratosphere, downward propagation to the jet streams at the border between the stratosphere and troposphere, the lower atmosphere, and those waves propagated downwards and spread across over to China, where they created extreme rainfall. I think there was some places that had almost 1.2 meters of rainfall, 3 or 4 times what you would typically get in that region, and that of course caused huge rises in rivers and caused a lot of overland flooding and large economic impacts on China. And so so there was a bunch of Chinese scientists who published this paper in Climate and Atmospheric Science, NPJ, peer-reviewed scientific journal, and it was just released recently. And it says that the likelihood of the extreme, or what it says is that the extreme rainfall event in China for the month of April 2024 was made about 54% worse because of the collapse of the Arctic stratospheric polar vortex. So this is a very, very interesting study, and what it means is that when these polar vortexes collapse, there can be extreme events at much lower latitude. So it's a very important direct connection between what's happening high above the poles and weather, at much lower latitudes. Okay, so let's go into the details of this paper. Okay, so I came across this paper by a Facebook post by Jan Umsonst on August 16th, and I saw the post just a couple days ago, and I was searching for it and on Jan's Facebook feed. And anyway, this is a post here, and I had trouble finding it. Why? Because look, he's posting prolifically. So there's many posts. This is 17 minutes ago, some graphs, and 20 minutes ago, some more info, and 55 minutes ago, chlorophyll values in the ocean, and then tropical Pacific stratification. I mean, this guy just never stops looking at science papers and posting about it. Here's increasing ocean stratification. So make sure you follow him on Facebook. There's lots of good information. I try not to miss any of his posts because he's got lots of good stuff on all kinds of aspects. So there's like dozens of posts, and you know, in the interim, from when I saw his post on the sudden stratospheric warming and Arctic stratospheric polar vortex stuff just a few days ago. Okay, so loads and loads of stuff. So this is the link to the journal and to this article, and let's get right into the article. So Arctic stratospheric polar vortex collapse amplified the South China extreme rainfall in April 2024. So in March 2024, the Arctic stratospheric polar vortex, or ASPV, collapsed dramatically. The following April, so the next month it should really say, extreme precipitation in South China, they call it SCP, South China precipitation, caused severe flooding and economic damages. Whether and how they are connected is crucial, yet unclear. Before this paper was published, so this paper hopefully, you know, clears up a lot of this connection. They used observations and model simulations. They demonstrated that the Arctic stratospheric polar vortex collapse in March of 2024, it amplified the extreme South China precipitation the next month. It propagated down from the stratosphere to the lower levels of the troposphere and was responsible for jet stream behavior, which then caused the extreme precipitation the next month. So as the stratospheric anomalies persistently propagated downwards to lower altitudes, the March Arctic stratospheric polar vortex had a pronounced impact on the North Atlantic tropospheric circulation in April. It excited eastward propagating Rossby waves. So the Rossby waves in the jet stream, they propagated from the west to the east over to China. The resulting lower tropospheric cyclonic anomaly over South China, what it did is it basically enhanced or increased the vertical motion, the convective motion. There was already moisture-laden air over China. Suddenly you got loads of vertical motion, so that water vapor rose to higher and higher elevation that cooled down, condensed into forming clouds, and there was massive rainfall. So it basically, there was enhanced vertical motion and therefore moisture transport, with vertical ascent dominating the extreme precipitation. So the biggest factor was the increase in vertical motion of the water-laden air. The Arctic stratospheric polar vortex's influence on South China precipitation ranked just behind that of the ENSO. The El Niño-Southern Oscillation was going on at the time, and that also enhanced the rainfall. And the effect of the polar vortex collapse was just behind the effect of the ENSO. So together they improved the South China precipitation predictability to 52%. So the weakened March ASPV increased extreme April SCP occurrence by 45%. So sorry, yeah, I said 52% or 54% in the intro. It's actually by 45% just from the Arctic stratospheric polar vortex collapse, and then the El Nino, the ENSO, adds to that. So what we're seeing here is a very robust polar low-latitude teleconnection. So we can relate the stratospheric polar vortex and the behavior of its collapsing to torrential rains at lower latitudes, which cause a lot of damage. So this gives you some level of predictability in the future. When we see a polar vortex collapse, we can know that certain regions of the world could be susceptible to torrential rains leading to flooding. So the Arctic stratospheric signal is a crucial predictor of South China precipitation and even low-latitude climate. It further aids in sort of mitigating and understand these extreme events. Okay, so this is a very interesting paper. So we know that the extreme precipitation can undermine water security, it can cause flooding, it can reduce crop yields, impede economic growth, and threaten lives. So the National Climate Center of China reported that South China, so basically 22 degrees to 30 degrees north, 108 degrees to 128 degrees east in longitude, suffered frequent rainstorms in April 2024. And there's some links, and I'll show you some of these links. So there was extensive rainfall over widespread areas, and it was very significant intensity. So a couple of the provinces in China had their wettest April in the climate records. The cumulative rainfall in eastern Guangdong exceeded 500 millimeters, or half a meter of rain. There's a place called Longmen County, don't know why it's called that, recorded an unprecedented almost 1,300 millimeters, or 1.3 meters, or 4 feet. 3 to 4 times higher than usual. I mean, they get a lot of rain in the monsoon, but this amount of rainfall is 3 to 4 times higher. The China Water Resources people said that the first 2 floods of 2024 that struck the Beijing River in the Pearl River Basin in April were massive. So the Ministry of Emergency Management of the People's Republic of China stated that floods and geological disasters in April 2024 affected 1.6 million people, ravaged 140,300 hectares of crops, and had direct economic losses of about 12 billion RMB. I think you need to multiply by about 15%. So that's about, that's what, about 3 billion or something, US dollars, if I got the conversion right. Okay, so basically they had unprecedented precipitation in South China, and a big factor was the March 2024 dramatic collapse of the Arctic stratospheric polar vortex. So there was a remarkable sudden stratospheric warming. The polar vortex reversed direction. The winds, the zonal winds at 60 degrees north and 10 hexapascals, so high up in the stratosphere, they instead of going west to east, they shifted from east to west. For 21 days, peaked at 21 meters a second in the east direction. This event was ranked among the 6 most extreme Arctic stratospheric polar vortex breakdowns on record. Now, there's studies that show the impact of what happens on surface weather and climate, including the East Asian trough, atmospheric blocking, surface temperature, precipitation, sea ice, snow cover, vegetation, the AMOC, as well as the westerly jet. All of these things can be affected. It can influence the monsoon. It brings in different phases of the Arctic Oscillation, North Atlantic Oscillation. So there's a lot of effects that happen when the stratospheric polar vortex breaks down. So they studied this. They looked at the data to see what would happen, and they found that the weakening of the Arctic stratospheric polar vortex in March, it increased the likelihood of extreme South China precipitation in April by 45%. So big impact. And they give results to that effect. So let's have a look at some of the data. Well, the first thing I want to show you is this is an image here, and links are all in the description. This is the polar vortex winds at 60 degrees north, 19 miles or 30 kilometers altitude. So where the pressure is 10 hexapascals. So the jet streams are much lower. They're at about 100 hexapascals or 150 hexapascals, something like that. So what you can see is the winds are west to east if you're above the line here, and east to the other direction to the east if you're below. And this is the typical line here, this blue line. And this is what happened in 2023, 2024. You had this huge dip starting in late February, early March, a huge dip, reversal of these winds, a breakdown of the winds as the in the stratospheric winds. Okay, down to minus 21 or so meters a second. So a huge reversal, breakdown of the stratospheric polar vortex, and this was the time when you had all of the problems in that followed here within a month of the breakdown in China that have been directly related. And there's just some articles that are translated into English from about the Beijing River having the first flood in 2024. So description of what happened. And then later on, so this was April 7th, 2024. And then this was April 20th. There was a huge river flood number 2. These are according to the China Water Resources website. And then there was also a lot of havoc. This is the Office of National Disaster that talked about the natural disaster situation in April 2024, which hit China, with the storms, these many people affected. Over 900 houses collapsed, 66,000 damage, 379,500 hectares of crops were affected. Direct economic loss is almost 15 billion won. Okay, heavy rainfall in the south, many rivers exceeding warning levels, severe impacts from floods. Okay, and severe convective weather, lots of storms across South China, and drought in other places. So they give basically a synopsis of what was going on there. And so this had a huge impact. So let's look at the connections here. So this is the Arctic stratospheric polar vortex strength, and you can see how it dropped down here. So this is March, beginning of March. It dropped down for March, and it was in April, early April through April, that you had the severe weather events. They show this is the winds in 2024 where you had a wind reversal. This is sort of the location. The stratospheric polar vortex was centered, not quite, it was offset here. This is the North Pole. It was offset a little bit. This side of the North Pole, it went right up to very, very high up into the stratosphere, the effects. So this is where the jet streams are, down at about this level. This is the upper part of the troposphere where it connects to the stratosphere, and this is all up in the stratosphere. And you can see here the big increase here in the rainfall. South China precipitation, millimeters per day. There is fluctuation, but we're right up here. This is the 95th percentile, up here, very, very heavy rainfall. This is a map of where the rainfall happened. It's interesting. There were 3 nodes, 2 out to sea, south and southeast of Japan, and then 1 hitting a bullseye in this red boxed area, which is the South China area, where I gave between, this is what, 20 north, 30 north, and 105 east is here, 120 east is here. So right over, bullseye target over South China, causing a huge event there. And they show how this is at 200 hexapascals, the different regions of the planet. The boxed area over South China is here. So you had winds being carrying precipitation up in this direction. And you can see this is the normal spread of South China precipitation, millimeters per day. And this was the event, which was exacerbated by the collapse of the Arctic polar vortex. Here, this is looking at rainfall, millimeters per day. This is looking at water vapor, specific humidity in the atmosphere. Huge amounts of moisture, a lot of convective uplift, it says, mostly vertical motion of the water, causing the moisture-laden air from low altitudes to much higher altitudes, where it formed massive clouds and rained out. This is at 100 850 hexapascals, which is about 1.5 kilometers up in the atmosphere. And you can see kind of, this is showing you the uplift of the air, you know, huge vertical uplift of the air. This is sort of the anomaly, the wind, you know, the wind divergence, the moisture going up into the air. So massive vertical motion brought all that water vapor up where it condensed out. And these are some of the images here of the polar vortex changes and divergence in the atmosphere, you know, where the polar vortex was, and of course that propagated right over to South China. Okay, so lots of information here, lots of data, and they showed the progression of the event over South China. So the precipitation, again, you can see, you know, one big huge band here, another one just south of Japan, another one over here, you know, also some heavy rainfall in these regions, and these are all sort of artifacts of the March Arctic stratospheric polar vortex collapse. Okay, and then they talk about the ENSO effects, right? ENSO also had a big factor in this particular rainfall event. So, you know, it was a combination of the ENSO situation and the weak Arctic stratospheric polar vortex situation that overlapped, causing this massive increase of South China precipitation. So many standard deviations above normal resulted in this extreme event. So basically, and they talk about it, this study is important. It establishes a polar low-latitude teleconnection, revealing the amplifying impact of the March Arctic stratospheric polar vortex collapse on extreme April South China precipitation in 2024. So in March, the Arctic stratospheric anomalies persistently propagated downwards through the atmosphere from the stratosphere down to the troposphere. It caused pronounced circulation anomalies in the jet streams over the North Atlantic at 200 hexapascals in late March, early April. These Rossby waves were excited over Western Europe, and they propagated eastward in two branches across the mid-latitudes and subtropical regions of Eurasia. The southern wave train induced anomalous cyclonic circulation, low-pressure areas, stormy areas in the lower troposphere over South China, significantly enhancing the vertical motion of the moisture-laden air, which was already there from the development of the monsoons in China. So combined with the regions with South China's climatological rainy season, this process greatly amplified heavy rainfall over South China. The wave-induced circulation anomalies also enhanced horizontal moisture transport across the oceans towards South China. It says this effect was secondary to the vertical ascent, the climbing air, the convective uplift over China. And then we had, so this study looked at those impacts and effects. It looked at the downward influence of the Arctic stratospheric polar vortex collapse on the surface climate beyond mid and high latitudes to low latitude regions. And they say that the influence of the Arctic stratospheric polar vortex collapse on South China precipitation was slightly weaker than that of the ENSO effect over the past 2 decades. So they know that ENSO amplifies these monsoons in China, depending on the state of ENSO. And the effect of the polar vortex was slightly weaker, but on the same sort of level as that of the ENSO effect. So that significantly improves the possibility of predicting, you know, that we can get April South China precipitation increasing it from 36% to 52% compared to predictions based solely on ENSO. So in the March Arctic stratospheric polar vortex is in a weak phase. The likelihood of extreme South China precipitation occurrences in April rises by about 45%. Okay, so this is really a very important study because it comes up with definitive connections between what's happening in the upper stratosphere over the Arctic and what's happening over China in this case. So I'm sure this study will be followed up by many others that look at, say, for example, how does a collapse of the stratospheric polar vortex affect, say, climate in Canada, affect things in the US, right? And so those are very important questions. And I tried to have a look at some of them sort of in a preliminary fashion. So perplexity.ai, please discuss the stratospheric polar vortex and how climate change affects it. You might recognize these images. This is a jet stream with a very strong polar vortex. As it weakens, you get these Rossby waves, this jet stream waviness occurring, outbreaks of heat waves and cold air and so on occurring. So the stratospheric polar vortex, it's a vast region of persistent cyclonic winds in the stratosphere, 10 to 50 kilometers above the surface of the Earth, forms over polar regions in the winter, serves as a cold air reservoir, basically trapping the most frigid Arctic or Antarctic air masses above their respective poles. It's maintained by a steep temperature gradient between warm mid-latitudes and cold polar regions. It's strengthened by the lack of sunlight in the winter, the darkness, complete darkness, 24 hours of darkness, right, over the winter pole. And its boundaries are marked by powerful west to east westerly jet streams. It's typically stronger and more stable over Antarctica because it's colder there. Also with the Arctic ozone hole, it's colder. You don't get heating from the ozone. There is, it's like gears. And there is also effects from mountainous terrain, land-sea contrast can affect it. It can set up waves which can lead to weakening, displacement, or even splitting of the polar vortex. And then you get extreme weather down to mid-latitudes because you get very, very wavy jet streams. Suddenly, you can get a sudden influx of energy from the troposphere. It can rise up into the stratosphere, and it's called a sudden stratospheric warming event. Can weaken and collapse the vortex and push Arctic air southward, which leads to cold spells in North America, Europe, and Asia. But also, we're finding out it can lead to massive rainfalls over South China. And the climate change's impact on the stratospheric polar vortex, of course, we have the Arctic amplification and sea ice loss affecting it. Of course, snow cover extent loss in the northern hemisphere affects it, but it doesn't say that here. Stratospheric temperature changes from greenhouse gas emissions. Of course, they warm the lower atmosphere, but they cool the stratosphere, as I showed you from the BAMS report in the last couple of videos. Can affect it. The ozone layer affects it. Ozone depletion is previously strengthened. The Antarctic vortex, sometimes we get an ozone hole over the Arctic, which can strengthen the Arctic stratospheric polar vortex. So there's more and more disruptions, and these disruptions, they can stretch the polar vortex. They can displace it off the pole. They can split it into two. Right? So winters with lower Arctic sea ice extent often see weaker, more easily disrupted vortices, greater risk of severe cold outbreaks. So they give an example: the U.S. intense cold and snowy weather in 2025 due to the polar vortex disruption. And there is a high chance for further vortex disruptions in coming years. There's other factors like the QBO, sea ice trends, etc., which are important. So they give a sort of a table here. The stratospheric polar vortex is a critical regulator of winter weather in the northern and southern hemispheres. Climate change, especially through Arctic amplification, stratospheric temperature changes, it's made the vortex more unstable, led to more frequent cold air outbreaks far from the poles. So paradoxically, a warmer world has not eliminated extreme cold spells, rather it may have made them more erratic and at times more severe. And then, of course, ozone depletion strengthens the polar vortex, and you basically, when ozone's depleted, there's less UV radiation absorbed, so there's less heating of the polar stratosphere from the UV capturing the being captured by the ozone, so that makes the stratosphere colder, makes the polar vortex stronger and more stable. So there's a definite link to ozone, and the cooling due to ozone depletion can delay the seasonal breakdown or final warming of the polar vortex, right? It breaks down as summer comes to that hemisphere. And so it basically, so the ozone is a big factor, and so a weakened polar vortex can be more cold outbreaks, increased frequency of cold waves, increased snowfall, prolonged extreme weather events, weather instability, things like that. And I also, what are the latest 2025 peer-reviewed scientific papers on the stratospheric polar vortex? So there's a bunch of different, there's some interesting new papers that have come out, and I'll have a look at these papers and probably do future videos on what's happening, because this is a very important area of ongoing research at the moment. And also I did ask about the Hunga Tonga volcano. Did it affect the stratospheric polar vortex? Because it was such a very, very powerful volcano under the water in 2022, and when it erupted, it sent a massive amount of water vapor and a moderate amount of sulfur dioxide into the stratosphere. This event was notable for sending material higher into the atmosphere than any eruption in the satellite era. It reached up to 58 kilometers. It sent water vapor 58 kilometers, so high up into the stratosphere. It added unprecedented volumes of water vapor to the stratosphere. Like, it increased the amount of water vapor in the entire stratosphere, I think, by 10, 15, 20%, something like that. And it did have changes. It was a southern hemisphere volcano. It did have changes, but maybe it significantly changed stratospheric composition and regional climate within the southern hemisphere, but there was no direct evidence it caused major sustained alterations to the stratospheric polar vortex. Okay, so that's interesting, and I think I did a video, I believe, on this volcano. I'll have to check in just, if you go on YouTube and just search in my videos for Hunga Tonga volcano, I think I did a whole separate video on this. But anyway, it sent massive amounts of water vapor up into the stratosphere. And you can see the spikes in stratospheric moisture in the recent report that, the State of the Climate 2024 report is still there years later after the volcano in 2022. Okay, well, thank you for listening. Please go to my website, paulbeckwith.net, and donate to PayPal to support my research and videos. Thanks again. Bye for now.